Welcome to Lesson 27, Part 1. Dividing by one digit using partial quotients, sometimes called the hangman version. Pages 79 and 80. Okay, our content objective, 4.NBT.B.6, so 4th grade, numbers and operations base 10. I can find whole number quotients and remainders with up to 4-digit dividends and 1-digit divisors. 4.OA.A.3, operations in algebraic thinking. I can determine how reasonable my answers are by using estimation. Language objective. I can use vocabulary related to division to explain how to divide multi-digit numbers. Social objective. I can work with others to create a model to prove the solution to the division problem. So strategies for dividing. Okay, we have the area model, the one we're going to do today, partial quotients, and there is a standard algorithm, but we're not going to learn that yet. You will learn this in 6th grade. Don't worry about the strategy for another 2 years. If someone wants to show you, tell them to wait until 6th grade when you are ready to ace this strategy. So we're going to help you have all the background so you're successful with this strategy. So here's 2 examples that we looked at. This is from our last lesson. 85, well, I can take 10 groups of 5 out of that. I get 35. The 35 comes up here. 7 times 5 is 35. We get 0. Add those partial quotients together, we get 17. And when we check divisor times quotient, we get 85. That matches. Here we get a similar thing, except for our partial quotients are on the side instead of the top. And our subtraction keeps going down. So 5 times 10 is 50. Take those 50 out, I get 35. 7 times 5 is 35. Take those out, I get 0. My remainder is 0. Partial quotient 17. Check. When we multiply the divisor times the quotient, we get 85, and that matches. Okay, so here's another way of looking at the partial quotients. Sometimes it's called hangman because it looks like that word game with the hangman. So here we're doing 855 divided by 7. So 100 groups of 7. Well, 7 times 100 is 700. That's what we're going to take out. We're taking out 100 groups of 7. When we subtract, we get 155. Then we're going to take out 20 groups of 7. 7 times 20 is 140. We're going to take that out. We get 15. 2 groups of 7. 7 times 2 is 14. 14 goes here. We take that out, and we're left with 1. So that's our remainder. Add these partial quotients together, we get 122. So up here, we can put 122, remainder 1. So if you ever see things with boxes up here, this is our total final quotient, the total quotient here, and then our remainder, whatever that may be. Okay. You want to use multiples of 10 when using partial quotients. There is no wrong multiple as long as the multiple is less than the dividend. So like here, I wouldn't want to have done another group of 100 because I would have 700 and that would be way too big. I need to make sure that the number that I'm getting here to subtract is less than what's already there. I can never have a number greater than. Alright, so now we're going to do some problems. So we're going to look at this problem right here. First we're going to estimate and then we're going to check. So remember, to estimate we need to get a compatible number. We're going to look at our divisor, which is 4. We're going to list our multiples of 4. So 4, 8, 12, 16, 20, 24, 32, 36, 40, 44, and they keep going on and on. So if I need more, I can get more. We're looking at 356. Look at that digit in the largest place. The greatest place is the hundreds place, and there's a 3 there. Is a digit 3 greater than 4? No, so that means we have to look at the first two. So what number in our list is closest to 35? Okay, it would be 36. So we're going to replace 35 with 36. And we have one place after, so we need one placeholder. So 360 divided by 4. Well, 36 divided by 4 is 9. If you didn't know that, you could count over 1, 2, 3, 4, 5, 6, 7. I missed one. Sorry. 7, 8, 9. And then I have one placeholder, moves it over one place. So our estimate is 90. Now this went up from 356 to 360. So this is a high estimate. So I know I can start with a number lower than 90. So let's see. It's close to 90. I'm gonna do 50 because I'm pretty confident with my 5s. And I know that 100 would be too big because I'd get 400. That would be too great. So a placeholder moves it over a place. 5 times 4 is 20. More on top, no need to stop. More on top, no need to stop. More on top, no need to stop. So we get 6, 5, 1. Let's see. I'm going to try 20 because I'm pretty good with my 2s. And the placeholder just moves it over a place. 2 times 4 is 8. More on top, no need to stop. More on the floor. Go next door, regroup 10 more, except for, I see that that's just a 15. 15 tens. 15, take away 8, that's a basic fact that I can do. So I get 6 here. 15 take away 8 is 7. Well, 20 would be too big because I'd get 80. So let's just do 10 groups of 4. 10 times 4 is 40. More on top, no need to stop. More on top, no need to stop. Let's see. Let's try 5 groups of 4 is 20. More on top, no need to stop. More on top, no need to stop. Let's do 4 groups. 4 times 4 is 16. Numbers the same, 0's the game. So our remainder is 0. If we add up these partial quotients, 50, 60, 70, 80, 85, 86, 87, 88, 89. Okay, so we want to check this. To check our answer, it's that divisor times the quotient plus remainder. We have a remainder of 0, and the identity property of addition says when you add 0, it stays the same. So I am just going to do the multiplying. I don't need to add the 0. 4 groups of 9 is 36. 4 groups of 8 tens is 32 tens, plus 3 more is 35. Does that match our dividend? Yes. So I can say the quotient is 89. Was that close to our estimate? Yes, very close. Okay. Let's do another practice here. So first we want to estimate. Our divisor is 2, so I'm going to list multiples of 2. 2, 4, 6, 8, 10, 12, 14. And then I'm going to look at my number, my dividend. Look at the number in the largest place, which is the thousands place. There's a 4. Is the digit 4 greater than 2? Yes, so that's the one I'm going to look at. Which number in the list is closest to 4? That would be 4. So that is our compatible number. And then I have 1, 2, 3 places behind. So I need 1, 2, 3 placeholders. So 4 divided by 2 is 2. And then I have 1, 2, 3, 2, 3. My estimate is 2,000. Now, this went down from 4,025 to 4,000, so that means that this estimate is low, and that tells me that's a good starting point for my division. So I'm going to start out with that group of 2002s. 2002s, that has 1, 2, 3 placeholders, and 2 times 2 is 4. That's definitely a good large group to take out. More on top, no need to stop. More on top, no need to stop. Numbers the same, zeros the game. Numbers the same, zeros the game. So I get 25. Let's see, I'm going to take 10 groups of 2. So 10 times 2 is 20. More on top, no need to stop. Numbers the same, zeros the game. 5. Can I take any groups of 2 out of 5? Yes. As long as this number is greater than our divisor, we can keep taking more groups out. So I'm going to do 2 times 2 is 4. More on top, no need to stop. I get 1. Can I take a group of 2 out of 1? No. So that's our remainder. We're going to add up these partial quotients. 2,000 plus 10 is 2,010. Plus 2 more is 2,012. Okay, so now we're going to check. To check, it is our divisor times our quotient plus our remainder. So 2,012 times 2. 2 groups of 2 is 4. 2 groups of 2 is 2 tens. 2 groups of 0 is 0. 2 groups of 2,000s is 4,000. And then we add our remainder. Does that match our dividend? Yes, it does. So we can say that the quotient is 2012 remainder 1. And that is close to our estimate of 2,000. All right, let's go ahead and do some more practice on the other side with our 3-column note.